welcome back. Today we're talking about applications of systems, so let's go take a look at example A. Here we are at example A, and it says the sum of Teresa and Kathy's weight is 118 pounds. Teresa weighs 26 pounds more than Kathy. If Teresa's weight is T and Kathy's weight is C, write a system to match the scenario and solve by substitution. So we've got some important information to cover first. First, we know that Teresa and Kathy's weight is 118 pounds, so that's important information. We know that Teresa weighs 26 pounds more than Kathy. That's important information. And we know that we need to solve this using substitution. That's important. So we have to follow all the things that they want us to do. So we first have to set up a system. Now, when we're setting up a system using word problems or application problems, we're looking for two pieces of information, or two things that we can write out as equations. So the first thing is we know that Teresa and Kathy's weight is 118 pounds. So that we know that Teresa plus Kathy is going to be 118 pounds. But that's only one of our equations. So the other equation we need to have is if Teresa weighs 26 pounds more than Kathy. So we can make sure that they're equal to each other so that we know that Teresa is going to be equal to Kathy, but only if we add another 26 pounds to Kathy's weight. So now we've got an equation where we've got a system where we have two different equations. Now, the next thing it asks us to do is to solve this using substitution. So we must use substitution by plugging in one of our equations into the other one. Now, good news, our second equation, we've already got it set up where it's equal to t. So we don't have to move everything around as one of our variables is already isolated. So we know t can stand for c plus 26. So we're going to plug that into our equation above. So we're going to use parentheses so that we end up with c plus 26. Close parentheses, plus c is going to equal 118. Now we can go about solving our equation. We know how to do that. So we're going to combine our like terms. So we're going to get 2c plus 26 is equal to 118. Now we're going to subtract 26 on both sides. So 118 minus 26 is going to give us 92. 26 minus 26 is going to cancel, and leaving us with 2c equals 96. Our final step is to divide both sides by 2. 92 divided by 2 is going to be 46. So we know Kathy's weight is 46. So we've got half of our problem figured out. Kathy is going to be equal to 46 pounds. And remember, we've got a word problem, so we need a word answer. So now we need to figure out Teresa's weight. So we can do one of two things. We can either just plug that in, or we can add 26 pounds to the 46 pounds we already know that Kathy's going to weigh. So it doesn't matter which one we do to get the correct answer. So I'm going to just add it to the 46 pounds that we already have. So 46 plus the 26 that we know she weighs more is going to be 72 pounds. And we could check that to make sure it's right, because if you add 72 and 46, you get 118. So we know that worked out. And we know that 72 minus 46 is going to give us 26. So it's going to be more than that. So it all satisfies our problem. Now let's move on to example B. Here we are at example B, and it says the perimeter of a rectangular wooden deck is 90 square feet, so that's important. Perimeter, 90 square feet. We've got the deck's length is 5 feet less than 4 times the width. That's important. Write and solve a system that matches scenario, and we can use the method of our choice. So that's nice. We can use either elimination, or we can use combination, or we can use graphing, or we could use substitution, whichever one we want. So now we've got perimeter of the deck. So we've got to come up with, again, two equations for our system. So we know the area formula for perimeter is 2 times the length times 2 times the, plus 2 times the width equals the perimeter. So for us, that's 2 times the length plus 2 times the width is going to be equal to 90. So that's one of our equations. Now we've got to come up with the other one. It says the deck's length is 5 feet less than 4 times the width. So we know that the other equation is going to be what length is it going to equal. And in this case, we know that it's going to be 4 times the width, so 4 times W, and 5 feet less than that, so then minus 5. All right, so now that we've got both of our equations, we can substitute or solve however we like. I'm going to substitute because one of our variables is already solved for. So we know that we can just substitute that right in for L, and we won't have to do too much other work. So I'm going to choose that method. So I'm going to go ahead and replace L using parentheses for 4W minus 5, close parentheses, plus the 2W that are there equal to 90. So now I'm going to go ahead and solve my equation. So I can do that by first, I'm going to go ahead and distribute. So 2 times 4 is going to be 8. So 8W minus 10 plus 2W equals 90. I'll go ahead and combine my like terms. When I do that, I get 10W minus 10 equals 90. Now I've got a two-step equation where I'm going to add 10 to both sides. These are going to cancel, leaving me with 10W equals 100. My final step is to divide both sides by 10. And when I do that, W is going to equal 10, or 10 feet. Looks like that's what we're doing here for our word problem, for our word answer. Word answer for our word problem. So now we know that the width is 10 feet. We can plug that right back into the equation where we knew L was equal to. So I'm going to say L was equal to 4 times 10 minus 5. And I know 4 times 10 is 40. So 40 minus 5 is going to be 35. So I know my length is going to be 35 feet. So now I've got both answers. The length is 35, my width is 10, and I'm done. Let's go on to example C. So here we are at example C, and it says Mr. Newman bought 8 tickets for his family to go to the carnival, so that's important information. He spent a total of $30, again, important information. He bought a combination of adult tickets for $5 each and child tickets for $3 each, so again, important information. And this time we have to solve using elimination. So that's important because we have to use the method they tell us. So now we're going to come up with our 2 equations. So the first thing is we know he bought a total of 8 tickets. We know that we have some adults and some children, but we don't know how many. So we know adults plus children, there's going to be a total of 8 of them. Now we know that he bought a combination of $5 tickets for the adults. So again, they're $5 for adults, plus our $3 tickets for children is going to be a total of $30, because that's what it gave us the information in our problem. So now we've got to solve using elimination. So that means we've got to get rid of our variables to be the opposite of each other. If I combine right now, that won't really work. So I've got to either turn that a to a -5, or I'm going to turn that c to a -3. I'm going to multiply everything by -3 so I can eliminate that c. Again, you could have chosen any of the variables to eliminate in either one of the equations, but I think this will be the least amount of work. So when I do that, I end up getting -3a. -3 times c is going to be -3c. -3 times +8 is going to be -24. So now I've done that, it's time to combine my like terms. So I've got, or combine my equations. So 5a and -3a is going to give me +2a. +3 and -3c are going to cancel, leaving me with just +6 over here. My last step in this one-step equation will be to divide both sides by 2, and I get a equals 3. It means there's going to be 3 adults there. So that's easy to plug back in, because I end up with 3 plus c is going to equal 8. I know that just subtract 3 on both sides, and we know that we have 5 children joining us. And we check that to make sure it's right. So if we do 3 times 5 for the cost of the tickets, right? 3 times 5 is going to give us $15 for their tickets. And we know there are 3 adults and their tickets cost $5. So again, 3 adults, $15 for a total of $30. So we know everything we did worked out. All right, so we know that we've got 3 adults and we've got 5 children. Now let's move on to the next example. Here we are at example D, and it says Palmer can work no more than 10 hours each week at her 2 jobs. So no more than indicates to me that I'm about to have myself an inequality, so I've got to make sure that I pay attention to that. It says lifeguarding pays lifeguard is paying $8 per hour, whereas ice cream shop is going to be paying $10 per hour. So ice cream's a little bit better. She needs to earn at least, so again, we've got more inequalities here, so needs to earn at least $90 each week so that she can pay her bills. The good news is we can use whatever method we'd like to go ahead and solve this. So the first thing we've got to do is write down our 2 inequalities. So it says Palmer can work no more. So we know that we've got lifeguarding plus the ice cream shop. And again, you can pick whatever variables you want. I picked L for lifeguarding, S for shop. And she's going to be making working no more than 10 hours per week. So we got to have less than or equal to 10, because she could work exactly 10 hours, but she can't work more than that. So it could be less. And then we need to come up with our other equation, or inequality in this case. So it says lifeguarding is going to pay us $8 an hour. So that's going to be $8 for our lifeguarding plus our $10 for every time that we work in the shop. And we need to make at least $90. So we got to make more than or equal to $90. All right, so now we can go about solving this any method that we want. Now, I will say with 2 inequalities that have signs that are not facing the same way, the fastest way to do that is to graph them and use your Desmos calculator to do so. But that's not why you're here. You're here to have me do it a different way. So I'm going to pick substitution because, again, I've got signs pointing different ways. So elimination would be tough because I got to get the signs facing the same way to do that when I go ahead and multiply and move some variables around. So that's going to be chaos. So I'm going to just go with good old substitution where I can try and get one of the variables by itself. So I'm going to go ahead and do that by getting L by itself. So in order to do that, I'm going to take my L here. I'm going to plus S is going to be less than or equal to 10. I'm going to go and subtract S on both sides. That's an 8. I want to be able to subtract S. So I'm going to subtract S on both sides. When I do that, I'm going to hit L is less than or equal to negative S. And again, I've got an 8 here. Negative S plus 10. All right, so now that I've got that variable isolated, I'm going to go ahead and plug it into my other inequality. So to do that, I've got my 8 here. I'm going to take my parentheses. I've got negative S plus 10, close parentheses, plus 10S is going to be greater than or equal to 90. All right, so now I go ahead and solve my inequality just like I always do. So I'm going to start by distributing. So I've got negative 8s plus 80 plus 10s is greater than or equal to 90. All right, now I got to scoop up and combine my like terms. When I do that, I'm going to end up getting 2s plus 80 is equal to 90. I'm going to go ahead and subtract 80 on both sides. I'm going to end up with 2s is not equal to, it's going to be greater than or equal to 10. And then my last step is going to be to divide both sides by 2. When I do that, s is greater than or equal to 5. All right, so I know s is greater than or equal to 5, so I can just substitute that right back into my other inequality at the top. So if I do that, I get s plus, now I just figured out that s is going to be 5, and it's going to be less than or equal to 10. So easy to figure that out. I'm going to subtract 5 on both sides. So subtract 5 on both sides, subtract 5 on both sides. These are going to cancel, and I'm going to be left with L is less than or equal to 5. All right, so now I've got my answers. Remember, this is an inequality, so there's going to be lots of solutions that make this inequality true. So for lifeguarding, anything less than 5 will work. So if I'm working 1 hour, 1.5 hours, 2 hours, 3 hours, all of those are less than 5. For the shop, I've got to work anything that's greater than 5. So again, 5 would work because it's equal to, but I got 6, 7, 8, 9, all of those are greater than 5, so that works out. If I had something like 4, though, that's not greater than 5, so that will not work. All right, now let's move on to the last example. Here we are at example E, and it says the Flynn family is hosting a barbecue. They go to the food store to buy burgers and hot dogs. Each case of burgers cost $8, so that's important information. Each case of hot dogs costs $5. They must purchase at least, okay, again, we've got ourselves an inequality, 4 cases of hot dogs. They cannot spend more than, okay, so again, our inequalities, $80. Write a system to match the scenario and solve by graphing. So good news, we get to use our graphing calculator once we've got our 2 inequalities. So the first one says the burgers are going to cost $8, so we've got 8b for that. And the case of hot dogs is going to be $5, and I'm going to call that h. And we have to have, they can spend no more than $80. So spend no more than, that has to be less than or equal to $80. Now for our other equation, it's going to be much easier because we have to have at least 4 cases of hot dogs. So the hot dogs, we can have greater than or equal to 4. All right, so now that we've got our 2 inequalities, we can type those straight in our graphing calculator. And if we do that, we're going to end up getting the point 7.54 as one of the solutions to our inequality. So what does that mean? This is where our lines are going to intersect. Well, because both of the lines are equal to, this is a solution to our inequality. However, we're talking about buying cases of hot dogs and burgers. We cannot buy 7.5 cases of something. That involves opening up one of the cases, and people aren't going to be very happy, right? So we've got to come up with things that are less than or equal to. And sure, 7.5 would work, but we can't use that in real life, right? We have to have amounts that we can purchase. So in this case, we could buy 7 burgers, right? 7 burgers or less, right? If we buy more than that, we can't do that, so less. And then with the same thing with hot dogs, we buy 4 hot dogs or more, okay? Again, but they have to be in amounts that make sense, right? We can't exactly just start opening up packages. We have to have a correct number that we buy from the store. All right, that brings us to the end of this example. It also brings us to the end of the set of notes and this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.